Good afternoon. You are here maybe because of you are interested in lipolysis, and today I'll explain the mechanism of lipolysis. Lipolysis is the process of triacylglycerol mobilization. Triacylglycerols can be synthesized in different organs, but the main place of triacylglycerol synthesis is adipocytes. Lipolysis is the process of triacylglycerols hydrolysis. And now I'll explain the concept of lipolysis. Here you can find adipocyte. This is adipocyte, and inside of the adipocyte you can find a lipid droplet. The first slide illustrates main components that will participate in my story in lipolysis, and I'll explain now which components are necessary for the realization of lipolysis. First of all, lipolysis is activated by contrainsular hormones. They are, for example, these are only examples: epinephrine, if you are in stressful state, for example, or if you are physically active; glucagon, if you are hungry, or again, if you are physically active; or growth hormone. 8 is hormone here. These hormones cannot penetrate through membrane, and that is why receptors for these hormones are located on the surface of adipocyte. Next component, DS protein. DS protein is the component of adenylate cyclase system, and this protein is necessary for the activation, for the stimulation of the next component. DS protein has GTPase activity, can hydrolyze GTP. GS protein in active state activates ADC. ADC here is adenylate cyclase. Adenylate cyclase is enzyme. This enzyme is necessary for the synthesis of cyclic AMP. Cyclic AMP is the second messenger for the action of these hormones, for the action of epinephrine, glucagon, growth hormone. These hormones cannot penetrate through membrane, and cyclic AMP inside of adipocytes will do all that these hormones want to do inside of adipocytes. Next component that I'll explain in my explanation, PKA, protein kinase A. If you know, kinases are enzymes for phosphorylation. Kinases phosphorylates different components, compounds, or in this case proteins, because this is protein kinase. In active form, protein kinase can phosphorylate. First of all, pyrrolipin A will be phosphorylated by protein kinase A. Pyrrolipin A is protein. This protein in dephosphorylated form can form the complex with CGI protein, and on the surface of a lipid droplet you can find the complex pyrrolipin A CGI protein. Inside of lipid droplet you can find here TAG. TAG is triacylglycerol. Triacylglycerol in the structure, this is the scheme of the structure of triacylglycerol. Triacylglycerol in the structure has glycerol and 3 fatty acids, 3 acylglycerols. For hydrolysis of 3 acylglycerols in adipocytes, there are 3 enzymes. These 3 enzymes are here. First enzyme is adipose triacylglycerol lipase. This lipase is located on the surface of a lipid droplet. Hormone-sensitive lipase, this enzyme is located in cytosol. And monoacylglycerol lipase. Again, this enzyme here you can find is located on the surface of a lipid droplet, but monoacylglycerol lipase can be located in cytosol. And a final component of this scheme is fatty acid binding protein. This protein is necessary for the transport of fatty acids that will be released during lipolysis. And now I'll explain the mechanism of lipolysis. We will start from our contrainsular hormones. For example, if you are in stressful state, your body weight can be decreased because of epinephrine action. Epinephrine as a hormone reacts with the receptor on the surface of adipocyte. After this, there is activation of GS protein. You can find here plus. In this case, we should read this plus as the activation. GS protein activates adenylate cyclase. In active form, adenylate cyclase synthesizes cyclic KMP from ATP. Cyclic KMP again activates protein kinase A. In active form, protein kinase phosphorylates perilipin A and hormone-sensitive lipase. First of all, about the phosphorylation of perilipin A. After the phosphorylation of perilipin A, the complex between perilipin A and CGI protein will be disappeared, and separation of these two proteins lead to removal of this complex from the surface of a lipid droplet. Protein kinase A phosphorylates hormone-sensitive lipase. And this lipase will move from cytosol to the surface of a lipid droplet because the pathway is free. If you remember my previous slide, here perilipin A CGI protein complex was and prevented the transport of hormone-sensitive lipase to substrates. Now again you can find hormone-sensitive lipase was in cytosol, and this complex perilipin A CGI protein prevents the transport hormone-sensitive lipase to the substrate. And again, protein kinase A phosphorylates perilipin A and hormone-sensitive lipase. And all enzymes are ready for lipolysis. First of all, I want to explain how adipose triacylglycerol lipase can be activated. CGI protein in free form, like here, is necessary for the activation of adipose triacylglycerol lipase. Without stimulation of adipocytes, adipose triacylglycerol lipase can be active, but this activity is very low. Without CGI protein in non-stimulated adipocyte, adipose triacylglycerol lipase can be active, I want to say again, but activity is very low, and this activity has interesting specificity. In non-activated state, adipose triacylglycerol lipase can hydrolyze triacylglycerol, but in this state, this enzyme can remove fatty acid from the second position of triacylglycerol, and 1,3-diacylglycerol will be formed. And 1,3-diacylglycerol is not interesting substrate for next enzyme. 1,3-diacylglycerol is interesting for resynthesis of triacylglycerols, and 1,3-diacylglycerol will be involved in lipogenesis. But our story is about lipolysis, and it is why I want to say about activated adipose triacylglycerol lipase, and again this lipase will be activated by CGI protein. In active form, adipose triacylglycerol lipase can remove the first fatty acid from the first position, and free fatty acid will be released. And the second product of this reaction is 2,3-diacylglycerol. This diacylglycerol is hydrolyzed by the next enzyme. This enzyme is hormone-sensitive lipase, and this lipase has been activated by phosphorylation. Hormone-sensitive lipase hydrolyzes diacylglycerol. This enzyme removes fatty acid from the third position of diacylglycerol. And we can find here again free fatty acid will be released from third position of diacylglycerol, and monoacylglycerol will be formed. 2-monoacylglycerol. This compound is the substrate for monoacylglycerol lipase. This lipase will remove fatty acid from the second position, and free glycerol will be formed, and next free fatty acid. The final products of lipolysis are free fatty acids and glycerol. Glycerol cannot be used again for lipogenesis because glycerol should be phosphorylated. Unfortunately, in adipocytes, glycerol kinase is absent, and free glycerol cannot be phosphorylated in adipocytes and cannot be used again for synthesis of triacylglycerols. And that is why glycerol will be transported into the blood and will be transported into, for example, hepatocytes or in myocytes. In these cells, glycerol kinase is present and glycerol can be utilized, but this is another story. Next, about free fatty acids. Free fatty acids are transported by specific protein. This protein is fatty acid binding protein. This protein transports free fatty acids in the blood, and in the blood these fatty acids will be transported by albumins to different organs where free fatty acids will be used as for energy production, as for synthesis of triacylglycerols or phosphoglycerides and other metabolic processes. This mechanism that I explained, this is new concept of lipolysis. And this concept was proposed to 2004, and for biochemistry practically this is a new concept, and I propose to use for you the same references that I used during preparing my lecture. Thank you very much. I hope my lecture will be useful for you.